Hello, everybody, and welcome back to a new episode of Zed Decoded. It's been a while. We're back. You can call this season 2 if you want. And today with me are Marshall and Max, both of which have built Zed Extensions, which are these extensions that you might have used, which Max wrote about in April and that have been around since then in Zed. And today we want to take a deep dive. So, welcome, Max and Marshall.
Thank you.
Thank you, Thorsten.
So I read the blog post. I've used extensions. I think, in fact, if I open my Zed here, and I check which ones I have installed, I have quite a few installed actually, right? But I have to admit, I do not know how they work. So what I want to figure out with you two is, if I have a file like this, which is a hello world.scala file, which is not syntax highlighted, but we do have a Scala extension here. If I install this by going again into our extensions menu here and I type in Scala and I click install, and now I go over here, I have sweet syntax highlighting. I want to know what happens under the hood. Like, what's going on here? I know that there's somehow trees that are involved. I know that these extensions are written in Rust, and I know that here they implement the extension interface, but I do not know how that even works. So basically, I need you two to explain to me what happens if I click install extension.
Awesome.
Let's dive in. Who do I follow? Like, what's the best way to start? Marshall, you
want to share your project?
Oh, sorry. Yeah, there you
go.
go. So now you can follow me. But basically, here, like, what on the install button, I guess. Like, how do we find this? I'll follow you, Marshall.
Sure. So yeah, if we jump into the extensions UI, then we should have, let's see, an install button in here somewhere.
So extensions UI is the thing that we looked at, right? It's this. It's a separate crate, and it basically is this UI here.
Yeah, that's
right,
the crate
exactly.
that has that UI.
All right. So if I follow you again.
Yeah, so we've got so these extensions are being pulled from our extension API. So like we
Wait,
have this registry.
Where are you? Oh, there you go. I got you.
So we have this registry that has all of the available Zed extensions in it, and that's fronted by an API that'll return metadata about these extensions. And so then what we do is we, render them into a list here. And so then we have, there's like each extension has a status, right? Like, so if you haven't installed it yet, then you'll see the install button. And so then what happens when you click that is we go into the extension store here and we install the latest version of that extension. And so taking a step back, all of our extensions, they're driven by this like Wasm API, and so they have and there's like different versions of that, right? It's almost like an ABI for extensions. And
so that's this thing, right? The impl Z extension. That's or is it not? Like that's basically the API they can implement.
Yeah, we sort of wrap there's like a Wasm ABI, so binary interface that we use to talk to different extensions, and over the months since we shipped this, there's like a few different versions, and then all those get wrapped into a Rust trait that makes it kind of convenient to implement that interface.
Okay, so Marshall, you were saying here, this is where we define. I guess let me turn soft wrapping on. Here.
Yeah, so when we install the latest extension, we're actually able to kind of look at, so each version of Zed has like a certain, like it has to have support for like different Wasm API versions. Like an older version of Zed might not support like a brand new version of the Wasm API. And so what we're able to do here is we sort of embed the supported version range into the Zed binary itself. So that way when we say install latest extension, we're only going to try to install versions that are like compatible. So it allows people to like put out a new version of the extension that's like using a new version of the extension API without having to worry about like, people trying to install it on older Zeds and having it not work.
Got it. And
so
we like in this comment here, we are the Wasm host. Like Zed running on my machine, that's the Wasm host.
Yes.
That's right, yeah. Zed is the host, and then the extensions are the guest. Yeah.
Okay.
Yeah, so we get these like different versions for like saying what we support, and then we say, okay, let me download this extension, that satisfies these parameters.
I see. Oh, so wait a second. So I could, if I have an older version, I can download an older Scala extension version too. Like I have an older Zed, and I say, I don't know, goes to version 5, extension API version 5, and I install Scala, then this would say, give me a Scala extension between these two, and like, does it fall back to older versions, or is it just saying not found?
Yeah, it'll basically try to install install the latest extension that is like supported by your version of Zed.
Okay, got it. All right. So then we get like an HTTP client, we get from our API, we get a URL back, and then what? We install or upgrade the extension. Here we go.
So we have this. So yeah, we go in here, and then basically what this is going to do is essentially just, go out to the server. It removes the directory in case it already exists, and then it's going to go out to the server. So it's going to hit this like HTTP endpoint, which is then going to give us back like a download URL to the actual gzipped tar that has the extension contents in it, and then we download that and then unpack it onto the file system.
I see. So then here, okay, we get like, so what's in that archive? I know that our extensions are hosted here, right? Zed Industries and then extensions, at least right now. Oh, that's more the registry, I think, right?
Yeah, so we have this GitHub repo, and this serves as kind of the source of truth for the whole extension system. So basically, anyone who wants to publish a Zed extension, they will go, add it there as like a submodule, and then what we have on that repo is like a CI system that'll run, and it'll actually like it'll like clone down the repo, it'll build the extension and compile like the Rust into Wasm, and also kind of copy all the like tree sitter files into it. It builds the grammars too, also as Wasm, and then it basically puts all those into like a kind of predefined structure, and then we zip that all up and upload it to our blob store. And then we have another process which it basically kind of is constantly scanning the blob store, and so when we upload a new archive there, it'll take that, create some like a record in the database with like the metadata about that extension, and then that's what makes it available to everybody. And we can actually we can like rebuild our like the state of the blob store from this GitHub repo if we wanted to.
So basically, when I hit install, it only in quotes unzips the already compiled Rust or whatever. I don't know. We can get into this in a second, but in that archive is Wasm, right?
That's right. Some config files, some TOML files, and some Wasm files. Yeah.
Okay, so can we take a quick look at the how do we compile this? Yeah, or how is this? Is it?
Oh, the code for building it?
Yeah, how do we compile
There's a lot of it's in the Zed repo if we want to stay in Zed. There's a CLI tool that we kind of shell out to in the CI of that repo. Marshall, you probably are...
If you follow me over to... So we have this extension CLI crate.
I see.
And so basically we have this CLI that we use to build extensions, and so we like publish this as a separate binary, and then this is what we call in the CI on the extensions repo. And so what this does is it uses this like extension builder, which is what we actually use this when installing dev extensions on your local machine as well. And so we like
so dev
have
extensions,
this compile extensions.
Just to add like a little interlude here, you can. Is this only nightly or is this also in stable? I don't know. But basically, you can install dev extension and point it at a folder, and then it compiles it, right, and starts it. You don't have to talk to the registry. So this is how you can do local development, I guess.
And that's that kind of uses the exact same code that is used by the CLI tool we were just talking about. And it's not just in Nightly, that you can do that on any Zed version.
Because I guess that's how everybody develops extensions, right? Like Okay. All right. So then here, compile extensions. We have a directory. We have a manifest, which is, I would assume, the toml file here, right? Extension toml.
Right.
Yeah, this is the toml file that like describes your whole extension.
Yeah.
And so this struct here is sort of doing double duty. Like it's in part the things that the extension author is going to specify, right? So it's like, ID, name, version, schema version. And so like these are the things that like we need to have. But then we also use this as kind of like our own manifest for, that's what goes into the tarball. And so, we have like all these extra fields like theme, languages, grammars, but like, so like some of these, like themes, for example, you don't actually need to list these when you're authoring the extension toml, because what we do is like during the building step, we'll like populate all these. And so the themes are kind of, they follow this convention where it's just any JSON file in like the themes folder will kind of get picked up as a theme. And so you don't actually need to like include this key here, but like, grammars, this is how you'd say like, okay, these are the tree sitter grammars that I want to provide. And it's a map of like the name of those grammars to like a manifest entry. And that's like where you say like, okay, I want to, build a grammar from like this repository at this commit. And you can even do like a path, like if there's multiple tree sitter grammars inside of a repo.
Okay.
And so you kind of tell us like where the grammar is, and then we take care of like, pulling down the code and like compiling it and then building it into the Wasm bundle.
Okay. So then we say this is where it is, this is the manifest, and then I don't know, then I guess the rubber hits the road, right? Like this is creating directories and then compile Rust extension.
Yeah, so there's the main way that we support writing. So conceptually, the extensions that have a few different pieces to them, like Marshall mentioned, there's the grammars, there's themes, but then there's like kind of an actual Wasm module that you can provide too, that is like your logic for your extension. And right now, that we are mainly focused on developing that in Rust. There's kind of ways we use a standard for what the interface is that makes it so that you could write extensions in other languages too, if you were okay with building it yourself. There's a few other languages that support compiling to this WebAssembly component format that defines our interface. I think Sig might be one of them. I'm not totally sure actually, but Rust is sort of the easiest. So this is the code path where we compile the main kind of Rust logic in your extension, and then we also, for all the grammars that you list, tree sitter grammars, we compile those to Wasm also, and they kind of end up as separate Wasm files.
So here the constraint is which language compiler supports compiling to this type of Wasm output, or like
there's like many languages can compile to Wasm, but we use this sort of new Wasm construct that's called a Wasm component. That's kind of a new part of the standard that's very cool. That is sort of allows you to, basically it's like a standard interface for representing all these high level types like maps and lists and structs. It lets you have like a very rich API that you can talk to extensions for, and it's not tied to any one language, which is really cool.
Okay, but it's not supported by a lot of other languages. It's supported in Rust.
The tooling is new, So there's Rust. There's like nascent ways of doing it for other languages, but Rust is kind of like has really good support for it.
Okay.
So I think that's a good segue into like, why don't we go take a look at one of these, like,
jump in here and compile Rust extension
interface files.
Yeah, so if you follow me to this like extension.wit file.
Okay, so what is .wit?
So WIT stands for WebAssembly interface types. And so it's like this language that they have developed for kind of defining these like Wasm APIs and basically like essentially what that API is.
Yeah.
And so you can see here, like, so this is our like main extension, and so we have like different files, so we can like import from these other files that like provide different APIs. So we have like stuff for interacting with like GitHub and downloading releases. We have a general purpose HTTP client.
I just want to jump in and say, maybe while we're looking at this, you could go to the extension store and install the WIT extension. Just kind of meta, but that way we'll have syntax highlighting for the WIT files.
This one here?
Yeah,
that one.
Install that really quick.
All right. Good call.
Anyway, continue talking about what's in the WIT
There
file.
you go. Graphbox Darkhard, we're back. Nice.
Yeah, and so you can see here we have like a pretty rich language that we can use. So like we have we can define like functions that are implemented on like in the Wasm extension. We have like regular enums. We also have like variants, which are more like Rust enums, where you can like carry state on individual cases. We have records. So yeah, it's just there's a very rich language that we can use, and this essentially like defines the contract between like the Wasm extension and the Wasm host.
So, who calls what here? If you say init extension, wait, this is export init extension. So
right, so exports are things that get defined on the extension side, and so you have to like implement those, and then the host will call them. And then imports are the other way. Those are implemented on the host, and then you can call them from the extension side. So it's like the
world extension here means everything in this block. Basically, this defines what an extension is or can do, and it exports this function, for example.
Yeah, so it exports like an init extension. We have some more exports like down here at the bottom, and these are like the things extensions can do, right? So that they can give you like the command for a language server to run, or you can get like the initialization options for a language server.
I see.
And one cool thing is that if we look specifically at language server command, this one, so we pass in some data to this where we in your extension, your TOML lists the name of your language server or servers that you can support, and so we pass those into you. But then we also pass into you this object called a work tree that's sort of like an abstract representation of a resource on the host side. So in the native side, that's like our representation of what project you're editing, what files it has, and so that exposes methods that the extension can call that are like native methods. It can read state about the work tree, so you can say read text file, read path, shell env to like spawn a shell in that folder to get environment variables. So that kind of gives you a feel for what the extension, like it can call into the host using like objects with methods, and then obviously vice versa, we can call into it.
So side note, why does this look so rusty? Is it rusty, or is this like what's the why does it? Is it just the way it is, like that it has option and result types, or did you add them somewhere, or?
No, those come standard.
Yeah, it was designed like since Rust existed. It's pretty new, and so it's got a lot of good ideas from Rust.
I see.
So these obviously like map to Rust enums and stuff. There's like a code generation crate that will take this and then generate Rust code on both sides of the interface, host side and Wasm side, that it can kind of like, on the Wasm side, it means that you can basically, like we were saying earlier, implement a trait, and then that causes you to be able to kind of implement this Wasm module with this interface. Okay. And then on the host side, you can implement these other traits like work tree and stuff that lets you implement the host side of this interface. And then the generated code actually like converts the types into this standard binary format that is used to encode all these things.
Okay, so we have this WIT file. It defines interfaces. And then you said we have code generation that turns this into generated Rust code that you can then compile against. I'll follow you.
Yeah, so there's two. We actually have two sides of the code gen, right? Just like there's two
Mm-hmm.
sides of this, like people using the WIT. So why don't we jump? We'll like jump over to the extension crate first. And so this is the actual crate that like, or
Mm-hmm.
sorry, not this Zed extension API. Um, so this extension API crate, this is the one that people will actually download from crates.io and
Mm-hmm.
like depend on. And so what we do here is,
Mm.
let's see, where is
So this is published on crates.io, and this is the
right?
thing that you pull in. I guess, wait a second. If I go in here and they have a cargo terminal, I should. Oh, there you go. So that's what we're looking at right now. This
For
dependency.
Right.
this, right, the
Yeah.
Scala extension.
All
Yeah.
right.
Yeah, and so in here, so yeah, we have we have the extension API defined in like this Wasm interface, but then we do a bit of wrapping on the Rust side to kind of make it more ergonomic to
Mm.
use. And so it's not like so if you were to use a different language, there would be like a bit of extra legwork that you need to do in order to get the same experience. And it could be that at some point we might have other like official packages that provide like the Zed extension API for the different languages that we support officially. So what we do in here, right, is so we use this crate called WIT bindgen, and we basically
Mm-hmm.
like point it at the current extension version. This one's this 020 is like unreleased. We're
Mm-hmm.
just sort of like we have it in the staging area. But
That's
what this does is
a directory of WIT files right there.
Oh, there you go.
and
I see. Mm-hmm.
and so then we call generate, and then this like generates a whole bunch of like Rust code, like structs, like all the types, like some like stubs for things. And so we have this in like a separate module, and then we like selectively re-export things. So like
Mm-hmm.
some things we just like re-export wholesale, like some of the types. But then in some cases we'll also like maybe shadow something if we want to like change the signature and do a bit of like wrapping internally.
Oh,
And
so
so then
this here, right? No, is this? I mean, so if I understand correctly, you auto generate code, which might not be the most beautiful code, and it's contained in this WIT mod now in Rust, and then you kind of either wrap around or you pass it outside. And when you wrap around, you try to make the API a little bit nicer.
right, yeah, because we want this to feel like a very kind of
Yeah.
ergonomic and like idiomatic Rust API. And so a good example of this is how like for this like set language server installation status function
Mm-hmm.
on the like Wasm side, it just takes like a regular like stir as like the language server ID, but we want to use this like kind of opaque language server ID type so that you're not
Mm-hmm.
kind of like interacting with it. And so what we do is we like create this wrapper and then shadow it, so that way you're kind of working in this like new type way when you're dealing with
Interesting.
this language server ID. And so then we also have so we have our own like extension trait, and so this is not generated by
Yeah.
the WIT bindgen. We like define this ourselves. And so the way it works is we do a bit of hackery here with like the init extension. So you call this like register extension method, which will like give us back. So it takes like a function pointer that gives us back like a boxed version of your the type that implements extension. And then what we do is we like store this in this like static mute
Oh, this
extension.
the extension. Okay, got it. Yeah.
So we have this like kind of global that's holding onto your extension, and then what we can do is then we implement the actual like Wasm guest trait for that component, and so then this will kind of delegate through that single the extension instance, and that's what kind of calls all the like the exports. So there's a bit of like indirection here again, so that we have like more fine-grained control. Because what we can do is like on the extension trait, we actually have default impls for
Default
a lot
impulse.
of these methods. So that way you get like a sane default. So you basically only have to override the methods that you care about in your extension, and the other ones you don't need to worry about.
I see. And then, okay, you have default impulse, and if I switch back over to the Scala one, which was, I've never done any Scala. This was the first one I picked or found. So this is the thing that we just looked at, this trade. They pull
Mm-hmm.
in they pull in the crate that we publish with the generated code, and then they implement this interface for their own extension, and then they call register extension, right? Which is the thing we just looked at, and then on our side we do the rest of this and,
Right,
and hook
exactly.
this up. So where does when does all of the code generation happen? Just to be clear on this. Like, we generate the code when we publish our extension API crate? Is that what it is?
Yeah,
It's
so
all
if you
via Rust proc macros at build time of the extension, so that
so like if you were to go, so if you go over to like docs.rs and look at the Zed extension API, then you can actually see like to the consumer it looks like we had handwritten all this Rust code basically because it's already there. So you can see we have all the structs and stuff.
Here it is. And then Enum Straits, there you go. A Zed extension. I see. And this is all, it doesn't even say anything about WIT, right? This is just
Right. Yeah, the WIT is not mentioned at all. So if you click on that one of those enums, like architecture enum,
I see.
So this is just straight up generated code, and so the code gen can read our doc comments on the individual variants, and then those get translated over to Rust doc comments. So it's just there's this really tight integration where we get really for the most part very idiomatic Rust code out of the box, and we have to just do minor changes to some of the APIs.
Okay, and you said it's generated on both sides, but this is basically what we're looking at, right?
Yeah. So okay. So this is right. This is the guest side. So this is what the extension will implement. So now we can jump over and look at the host side.
Okay. So guest side, we define WIT for both sides. Then here we have extension API crate, in which we bind gen or generate Rust code from WIT. Then we wrap the generated Rust code in our code and export a nice API, which extensions can compile again. But now on the host side, we need to also call and use those extensions, right?
Yes, exactly. So in our extension crate, we have this Wasm host module, and so here we'll look at the version 1. And so here we have another bindgen call. This time it's Wasm component bindgen. So it's there's actually two different bindgens in play here, one for the guest, one for the host. Yeah. And so on this side, it's we can give a couple different options. So we point at the WIT folder that we want to use. We set async true, which means that even though on the Wasm side everything appears synchronous, but on all the implementations are actually asynchronous, so that you can it's the host is running things asynchronously, but it presents as synchronous to the guest.
And this is super cool if you want to drill into that. That's so many things to drill into. But
yeah, but so let's drill into this because I'm. Wait, so you tell the guest this is a synchronous function, right? That you can call the get language server command or something. But then from the host perspective, this is all async, right? And it generates async code. But my first question is, how does it know which async runtime to pick, and how does it know? Does it even play a role, or is it just futures and it doesn't care about who's executing?
Yeah, it's just futures. It's basically whether the host methods have async fn or if they're just regular fn.
I see.
And that's the primary difference.
Okay.
Yeah, and so there's all these host APIs that we expose, the ability to download a file from the internet or run npm or something, and they obviously those want to be async because they do all this IO, but we can expose them. When the extension calls them, it just calls a synchronous Rust function download file. And when the host yields during the course of that async operation, the Wasm runtime is just suspended. So the Wasm code running in the runtime doesn't have to be aware of the asyncness at all. It just, the entire runtime just suspends. So I think it's really cool because there's a really simple programming model for the extension.
Okay,
and yet it supports async.
So basically, full use of abstractions. You compile an extension to Wasm, you execute the Wasm in the host, which you can then also look into, and you need like a virtual machine to execute it, right? Or something to execute
Wasmtime. Yeah, we use Wasmtime.
So, and then if the compile code calls a function, it thinks it's synchronous, the Wasm Wasmtime calls out to our Rust code, but in that way now it's async and it lets us do other things while it's blocked on IO or something. But from inside the Wasm code, it still looks synchronous. Is that right?
Yeah, exactly.
Okay.
And yeah.
That's crazy.
Yeah, it's pretty crazy. But it's a good, like, we didn't want to have async Rust. I'm glad that the extensions don't have to know async Rust because it takes the complexity up a little bit and it requires more libraries to sort of operate in an async way. So the extensions are really nicely simple that they're just synchronous Rust. They can use STD APIs.
I gotta ask this, to go on a tangent here a little bit. Or not a tangent, but I'm looking at this, and I know that you two are excellent programmers. I don't want to take away from this, but it looks like this all fits together perfectly. And either you made it look that it fits like together perfectly, or something else going on, because I feel every time I looked into Wasm, there was like all of these different runtimes and components and standards, and this language wouldn't work with that. Did you run into any of that at all, or did you just realize, hey, we want an extension system in Rust and we want to use Wasm for this? Here's the WIT stuff. Here's this. Here's that. Or
so the story is actually pretty crazy because this was back in, I think, like January-ish. Like, we had just open sourced Zed.
Yeah.
And we were getting this huge influx of people wanting to add support for every language under the sun, and it was like becoming this big kind of burden to have those all in core. And we're like, okay, we really need a way to kind of offload some of this onto extensions so that people can add any language they want without needing to put it into Zed itself. And so when we were first playing around with the extension API, we were actually initially going with like a JavaScript direction. We were going to like embed like a JavaScript runtime. We were looking at like Dino's V8 bindings. But then so Max and I were working on it, and we were like, we don't really want to write JavaScript. It's like we want to write our extensions, in Rust. And so there had been some like prior work by someone else kind of like looking into, Wasm for like extensions. But at the time it was like, it wasn't mature enough. And so it was sort of, fizzled out like it. But then Max was like, hey, it's like, let's look at this again. And so we found the Wasm component model, and it was like all this stuff had just kind of recently become usable in like the past few months. And so it was like we were in the right place at the right time. We like did a proof of concept. We're looking at the docs. We like got kind of the Wasmtime and like the Wasm component model plugged in, and it's like everything just sort of clicked together at that point. It's like and at first we were like, we had like some doubts, specifically when it came to like implementing that like sync async like disconnect, because like we needed to kind of work that into GPUI's async spawn model. But then as soon as we figured out like how we could make that work, we like knew that we had struck gold with this. We like knew that it was going to work.
That's cool. So it is right place, right time, like I said, plus excellent programmers, and then it turns out, like, I don't know, I'm amazed that it fits this well together, right? Like, every time I looked into Wasm, not to discredit anyone's work, but, there's a lot of work in progress stuff, and there's lots of community efforts that kind of morph or stop or take different turns. And I'm like, I don't know, this looks like it was built specifically for this use case, That's pretty cool.
Yeah, the Wasm component model is very new. Like Marshall said, it had just landed in Wasmtime. It was
Mm.
all working when we went to do this, and so we're still kind of betting on a new thing. But I think it's like a really important piece of making the Wasm integration story less of a
Yeah.
Rube Goldberg machine with all this custom
Yeah.
built stuff, because it's
Yeah,
really
yeah,
cleans
yeah.
things up.
Okay,
Yeah,
so
actually, what we have up here is actually a good talking point into how we sort of do backwards compatibility within our extension system, because we've actually put out multiple different versions of the Wasm extension API so far and included breaking changes.
so different
Um,
versions means that basically you can release a new extension version and this now takes another boolean or something and you break.
exactly,
Okay.
right? We can like change the contract,
Okay.
add like variants to enums, like
Yeah.
add new
Yeah.
functions, remove them. And so we're actually looking at v010 here, which is like the current published one.
Yeah.
But these like statements here in this like with block, what we're able to do here is we can say like, okay, so like the GitHub module has not changed between like 010 and 020, and so what we can say is like, okay, this is like a WIT path, so it's got like
Mm-hmm.
the kind of namespace, the world, and then the module name. And so we say, okay, this hasn't changed, so for anytime you see this, just go and use like this implementation, which we like pull from the latest. And so one of the reasons why we initially kind of broke these up into these distinct modules around functionality is it makes our migration story a lot easier, because it means we only sort of have to have duplicate implementations for things that have actually changed. And so if we go and jump over to like the latest version of the Wasm extension API, whoops. So and then we can like go down, and so here we actually have the implementation for like the GitHub host trait. And so this is something that like the Wasmtime bindgen generates for us. It like generates these traits for kind of
Mm-hmm.
each of the host implementations that we need, and then we just implement these on our Wasm state type. And then you can kind of see what we're doing here. So so it's like an async function, and so we need to
Yeah.
use async trait here. And then what we do is we can like call. So here we're calling like our internal HTTP client to like get the latest GitHub release, and then we sort of massage that back into
Wasn't
like a
time.
Wasmtime result.
Okay, so
and so
wait, how does that means you could, but you cannot independently release like a new GitHub submodule or something. Like what to go back, like you said, we don't have to have duplicate implementations for different versions. What does that mean? Like you can compose it of different WIT modules?
Like at a high level, if you sort of contrast this with some other extension APIs, like say it was all sort of like, say we had a JavaScript API and we weren't using WIT, then oftentimes we'd be like, oh, we want to, a new version of Zed, this function is going to take a new parameter, but we still want to support the old one. Like we did this all the time in Atom, and we just had if statements that said like, if the version is less than this,
Yeah.
call it with this signature. But this is like a totally different model where there's sort of a explicit, strongly typed interface for every single version of the crate. And so conceptually, it's different WIT bindgen calls for every version. So we have to kind of your starting point is you have a completely different set of types and traits and everything for every version, and it's all strongly typed. They're separate modules. But what this lets us do, the fact that there's submodules lets us like reuse subtrees of that module hierarchy, if that makes sense. Like version 0.1 and version 0.2 are completely different modules. Every single, like we have the ability to have a different type and trait for basically everything in there. But then it's a little annoying to have like a duplicate implementation of those of the host side of those two interfaces. So what we can say is like, while retaining the ability to load all these historical versions, we can say like, but these two versions share an implementation for
I
GitHub,
see.
GitHub
I see.
stuff.
I see. Okay. That's cool.
Yeah, here. So here, let me, if you follow me, I'll like show you kind of how we do this like backwards compatibility.
Yeah.
So we have this like extension enum here, and so we have a variant for each version, and so then each version it's holding like, this extension struct for that particular version. And then, so then what we do here is we sort of like have this wrapper implementation for extension that has like all the various methods, and then what it does is it like, based on the extension type that you're loading, it will then delegate to the appropriate implementation. And so here when we like, initialize an extension, we're like calling this, call init extension method that is specific to that version.
I see.
And same thing here, like let me find one where maybe like the contract changed between something.
So the extension says I want to run against version, 006. And then you init it and give it this different interface, which is also generated, and it's like you said, Max, like it's not, you don't have to do that switch. You get different versions compiled, or you just define different, Rust files and whatnot, or different WIT files, and you compile them into different Rust code, and then you say this extension wants this old version, so we call it with this Rust code.
Yeah, all the extension does is it sort of imports a certain version of that API crate that we publish.
Okay.
And then part of what that crate does is it puts there's like a kind of a special field in the binary that like makes it statically available to list like, what version is it using? Okay. And then when we load extensions and there are all these mixture of different versions of the API that they implement, they get represented at runtime in Zed as like different Rust types. Like there's sort of this Rust type that's like extension v1. It has a certain interface and etc. So we do have to. That's why we have this enum, so that it kind of represents any of the extensions.
Right. Yeah. So like Max said, when we're actually building those Wasm bundles for your extension, it's like based on the version of the extension API crate that you used to make your extension. We take the version of the extension API and then we embed that in the Wasm binary so that we can then read it when we're loading it, so that we know like, okay, we look at the binary, extract that version number, and then we say, okay, which code path do you need to go down to load, your version of the extension API that you're like built against.
So the extension CLI tool that we looked at that compiles the extensions, that says, you're importing our extension version so-and-so. I'm going to compile you and put this piece of information in the Wasm binary. Okay.
Right.
All right. And then, okay, Marshall, did you want to dive in deeper here, or?
Yeah, I was trying to find, I'm trying to remember
Let me close
which of these like had its signature changed, just so I could kind of show off what that looks like. I mean, I guess here's a good example for like completing a / command for the assistant. So we didn't introduce this API until v010, and so what we do there is like, so if we call this, like if we try to call this and then the extension is on an older version, then we just return an empty vec, right? Because like it didn't exist at that point. But then it means like if you upgrade your extension and use like the newer version, then you're able to like provide that functionality. And so that's like a case.
Okay, and that's how you can pick and choose, because for other, I don't know, like here we have 20, 10, and 1. I guess it's the same, but here's 6. So if nothing changed for a specific extension call, you don't have to add that match statement, right? Because if it's been stable for all the versions, you can just call the old version. You don't have to worry about this stuff.
I think you do still need to like have the match, because you're calling these methods that have the same signature, but they're methods on like different types. So they're like distinct code paths, but it's like the code is kind of very rote for the most part. But we can also do things like, if we're like if we add like a new optional parameter to like a function, then we can like, pass like none for like some default value that was sort of like implicit in the older versions. And so then that's what allows us to kind of support multiple versions of the extension with kind of like a single code path.
I see. Okay, so what we're looking at here, impl extension in the Wasm host directory. So this, like, where is this called? By whom? Like, how is this wired together?
Let's look at this example of a language server command. So this is like the call that tells us what process to run for a language server. So here, there's a few layers of indirection, but it's in this, we have this trait in Zed called LSP adapter that has implementations for Rust and a lot of the different languages that we have built-in support for. And then there's like one other implementation of the trait called extension LSP adapter that is the one that we use when we're doing extensions, obviously. And so here we, in order to define this get language server command, we actually call into this extension method. And then we do, what is it we're doing here? Yeah, this is kind of an interesting, like, sort of bit of code here where we say path from extension. Because the extensions, they sort of don't see the whole file system. We use this construct called WASI, WebAssembly System Interface, which is sort of like the I/O layer for Wasm. And so when an extension like uses the standard FS module to like read the file system, it kind of can only see inside of a certain folder. And it kind of thinks it knows that's the current working directory, but it thinks that it is some path like / I forget. We kind of give it a certain virtual path that it sort of thinks that is. And then so it'll often, like, extensions will download stuff from the internet and put them there, and then like chmod them or extract them and stuff, and then return a path to that to us. And so this is like the layer where we say, okay, now what's the actual path to that that file?
So here, this LSP adapter, impl LSP, this is like, who calls this? Like, I guess we call this. I know where that code is, where we say we want to start a language server for this language, right? But then, like, here it says, oh, here's the Wasm extension, here's the type, and it calls into the extension, right? Or how does this code work? Maybe here, extension call.
Oh, yeah, we have a little bit of this wrapper function. We have this call interface that sort of takes a callback, and that's because
the async.
I think in certain code paths we want to be able to call this function here that we're defining. I think we probably call this on the main thread of the app. But extensions sort of are, none of their code is running on the main thread. They run in this kind of dedicated background task, and so this is the way every time you interact with them. The way we designed it right now, you take this function that sort of gets their actual the extension object, and it gets called on the background thread where the extension sort of runs.
I see.
And then you kind of return a future, and the output of that future gets sort of sent back to the main thread.
Okay, so this is you schedule this to be executed on the thread, basically.
Yeah. So if you jump into the call implementation here, if you just like go see where that's implemented. So what we do here is like, so we're actually like, we have this, this sender, and so then we like do a send where we like send this over a channel, and then there's this like Wasm state on main thread where basically it'll kind of like read from that and then do the work on the main thread and then like send the result back.
That's this one down here.
Yeah, that lets you go the other way. Not all extension APIs need to do that, but when an extension needs to read the current value of a setting, is one place where we use that. It has to talk back to the main thread to get that setting, and that's one place where we use that on main thread.
Okay, so
And
then to jump all the way back, we download the Wasm module. How do we? You said we use Wasmtime as the Wasm VM. Like, how do we initialize this and call this?
yeah, there's this hook called extensions updated. If you follow me on our sort of extension store struct, that kind of this is what tells you basically that gets called anytime you add or remove an extension. So it's kind of about like unloading extensions that you that
Yeah,
you say you rebuilt the dev extension or upgraded or just turned off an extension, and then you load the others. And it kind of lists out all the things that extensions, the ways that they can interact with the app, and so you
yeah,
can turn those on or off. So there's themes, there's languages, um,
I see.
and there's a few there's slash commands like for the assistant, like Marshall mentioned earlier. And so if we take, for example, extensions that define language servers, there's this code path here where it's all sort of very statically listed what
Mm-hmm.
resources an extension provides in that struct that we were looking at earlier, the extension
Yeah,
manifest. And so we can kind of say, okay, for all the language servers that this extension says that it provides, we're going to register sort of this adapter
I see.
object that kind of the
Yeah,
extension
yeah.
adapter kind of references a particular Wasm module plus the name of a certain language server that we know that that module provides. And so that this is kind of adding or removing those resources whenever you turn on or off an extension.
And then, okay, we pass in the extension, which is Wasm extension. I want to quickly look at that type, which is, oh, that's it. Okay, so that's the channel for an extension call, manifest API version, and you pass in the host, Wasm host, which is the engine and like all of the dependencies that you might want to pass to an extension, right? Of hidden behind an API or an interface.
Yeah, so for any kind of host function that the extension can call that's not like a method on some object that's passed in, but just a function that's available, like we have a
Yeah.
download file that we need to sort of, the Wasm host needs to have the, like you said, the dependencies needed
Yeah,
for
yeah, yeah.
calling that.
Okay. Man, that's cool. So taking a step back, we got 4 or 5 minutes left. It's been 6 months. How happy are you with this setup? How has it played out?
I'm mostly very happy with it. We kind of along this journey glanced at a few code paths that were like, we talked about how there's a GitHub repo that is the source of truth for the list of all extensions. So that's something that probably won't
Yeah.
forever be the case. It requires a lot of manual effort by us to curate what ends up going into the extension store, and that was sort of the simplest way for us to do that. So that part will probably not last, and eventually we'll have some kind of self-serve publishing. We saw the boilerplate required to call into many different extension versions.
Mm-hmm.
That's like the one bit of code that is not like I'm not in love with about our extension store, but is very, even though there's boilerplate for like saying if it's v0, if it's v1,
Yeah.
if it's v2, it's very easy code to write.
Yeah.
It's not like, I don't know. So that'll probably stay. That's kind of a, unless the whole WIT component system develops a more mature way of versioning
Yeah.
packages, which might happen, and then we might have even less complaints. But really, I'm super happy with the extension system. Another thing that we saw on the way was that extensions, we mentioned, kind of have to be written in Rust here for right now for what we support. I think, Wasmtime is kind of implementing this another really bit important feature of Wasm, which is Wasm GC, which will make it possible to compile a lot more languages to Wasm conveniently. So we can start to have extensions written in like Lua or
Go or whatever.
JS or other languages. which is possible now, but is not as optimal
Yeah.
because you have to compile the garbage collector to Wasm. So I don't know, but even if it never changed and we always had to write extensions in Rust and do all this, I would be, having written a JS extension system and evolved it over the years in Atom, I'm very, very happy with this kind of point in the trade-off space that we arrived at. And we didn't even talk about part of what pushed us toward Wasm also was the fact that we have tree sitter grammars that we need to, that are not written in Rust. They're completely different. They're kind of written in C, that we wanted to be able to run in a way that was sandboxed and extensible, and Wasmtime let us do that part too. So the fact that it does that and then also lets us have this extension API is pretty great.
Cool. What do you think, Marshall? Do you think that, like, I you probably hear more about this than I do, but lots of people are asking, when will you add the ability to do X in an extension? Do you think there's going to be barriers, or do you think this way is the way?
Yeah, so I think, there's a whole lot of extension surface area that we're missing, right? Like, I think we're only just, like, when we were at Zed Summit in Montreal, we were starting to explore, like, how can we expose some of the, like, functionality for interacting with the editor, into an extension. And that's kind of like the next step is like, okay, we can do like themes and like language servers and languages. It's like, what is the next step for like kind of interacting with Zed from an extension? There's like this whole also unexplored space of like, in VS Code, there's lots of extensions that bring their own UI, which is all kind of, very easy because it's like everything's in a web browser. And so you can kind of just provide your own browser UI. So we haven't even begun to think about like, what does it look like? Will we have a way for extensions to bring their own UI, and like how does that look between like GPUI and like the the Wasm components? Like how do those things mesh together, if at all? So that's like another future area of exploration to see like what it would look like to support that.
But do you think you don't see any barriers here? At the end of the day, like, this allows us to do a lot of things, right? We can just call into any piece of Rust code that we want, and it looks like with the WIT stuff, we can expose anything we want, basically. So it looks to me like there's no built-in barrier to, say, allowing extensions to show modals or whatever.
Yeah, I think, there's definitely going to be things we uncover as we, like, explore these new areas and figure out like, the best way to, expose them to, to the extension system. And I think we'll just, we'll learn as we go and like tackle things as we come to them. But I think we have like a very solid foundation for kind of building out more and more extensibility into Zed.
Okay. Very cool. Thank you for this deep dive. I don't know. Last question. Do we have the most surprising extension that somebody submitted? Does anything come to mind?
So I think my favorite extension that someone's done is they added Discord presence as an extension. And so we've actually seen this kind of like, again, because we're like missing some functionality in the extension API, we have people who are kind of bridging that gap using language servers. And so the person who has this Zed Discord presence, they like wrote their own language server that like listens for, the language server events to figure out which file you're in. And then so they have an extension that installs this custom language server, and it'll like see like, oh, you opened like, compiler.go, and then it goes over like IPC to talk to like Discord and say like, oh, update Thorsten's status to be like, editing compiler.go in Zed for, this amount of time.
That's beautiful. So we basically said the only thing that extensions can do now is themes, grammars, language servers, and they went, challenge accepted. I'm going to build something else, but it's going to look like a language server to you guys.
Yeah, it turns out you can do a lot of stuff with the language server protocol.
Nice. That's really cool. All right. Then thank you so much, guys. Yeah, I'll see you around.
All right. Thank you, Thorsten.
Thank you, guys.
Bye-bye.
Bye, Thorsten.